So over the last few weeks, we've been talking about electricity, and we found out that electricity is just moving electrons. It's electrons that are flowing down a wire. Now, in order to get those electrons to go somewhere and do something, you need to give them a path to travel on. And we found out that electrons can move down materials called conductors. So if you can make a path out of, for example, copper wire that the electrons can travel down, you can send them somewhere and you can get them to do some sort of work, whether that's making a light turn on or a motor run or something like that. So last week I got you guys to play around a little bit with the circuit builder. And hopefully you're able to get a light to turn on. And in order to do that, you would have needed your battery. And then you would have needed to use your copper wire to connect one end of the battery to the other. And along the way, you would have needed to add a light bulb. And you'll notice the light bulb has kind of one entrance and then an exit, right? It has 2 points you can connect to. And you'll notice that if it's disconnected, there's no pathway for the electrons to flow, so they just sit there in the wires. Right? And the electrons are in the wire, right? The wire is full of electrons, right? All of the atoms have electrons around them, but they have nowhere to go until I connect up the circuit. And now the electrons have a pathway to flow. So they can start moving in that wire. When they get to the light bulb, they can heat up the element inside of the light bulb, and that piece of metal will start to glow when it gets hot, and now you have light. So today we're going to look a little bit more at these circuits. All right, so a couple spots for us to fill in here. Electric circuits. So electric circuits provide a path for electrons to flow. And anywhere you're using electricity, you have one of these electric circuits. So the light bulbs in your house, right? The lights in your house. Your stove is an electric circuit. Your toaster is an electric circuit. Your hair dryer. The wires that run in your house are an electric circuit. And even in your cell phone, there's an electric circuit. So anything that's using electricity has some sort of electric circuit in it. And that's really just some pathway that the electrons can move down and do something. So remember that a conductor, such as copper, is full of electrons all the time. As soon as you give power to the circuit, as soon as you connect it up to a battery or the power grid, then electrons will start to move. So you've given them a conductor to move down, they'll start to move. So this is a bit different than a water hose, right? Because if you think about turning on the water, it takes time to fill up the hose before the water starts shooting out. This is different though, because your copper wire is already full of electrons. They're already around all of the copper atoms. So as soon as you turn, for example, your light switch on, those electrons just immediately start moving, right? That's why your light doesn't need to power on, it just immediately turns on. So electricity is essentially instantaneous. You turn it on and those electrons immediately start flowing. All right, so what is a circuit diagram? Because that's what we're going to be looking at drawing today. So it's really just a diagram that shows what parts are in your circuit and what order they're connected together. And that's it. So this is useful if you're trying to build something, or if you're trying to show someone how you build something. Right? So if companies are designing their next hair dryer that they're going to sell, they need to figure out what parts are they going to connect in what order before they can even make the hair dryer. And that's what a circuit diagram would be doing. It'd be showing, okay, you need some sort of power source, you need some sort of switch that you can turn it on and off with, you need a heating element, right? You need probably some sort of motor that's connected to a fan to blow the air. Right? So what order are you going to connect them in? And what components are there. Throughout the lesson, you'll notice that sometimes instead of saying battery, we use the word cell. Okay, so another word we can use to represent battery is cell. So for example, we might say, oh, this is a 3-cell battery. Really just means it's like 3 AA batteries connected together, for example. All right, so many of our circuits are connected to the power grid, right, when you plug something into the wall, but a lot of them are also run off of batteries, right? So if you do have a battery in your circuit, you would draw it like this. So this is the diagram to show a battery. So that would be a single cell battery, so like 1 AA battery, for example. You would draw it like this. So here's your wire, and then you just have 2 lines, a big line and a small line. And you'll notice on a battery that one side has a plus on it and one side has a negative. If you go look at a battery, you'll actually notice that it has a little plus and a little negative on each side. And what that's showing is what direction the electrons are being pushed in. So electrons are negative. Right, so hold on, let's think about this here. What happens if you have a negative and a negative? What do negative and negatives do to each other? They repel each other, they push each other away. So in this case, the electrons are negative, they'll be pushed out of this end of the battery. And when they loop around, once you connect it together, a negative and a positive will attract, so it'll get pulled towards this end of the battery. So the electrons will always get pushed out of the negative side, flow around your circuit, do whatever they're doing, turning on the light, and then they'll get pulled towards the positive side to complete the circuit. So your battery always has a plus and a minus on it. The minus on the small side, plus on the big side. All right, 2 batteries. Similar sort of idea, right? We just draw 2 of these things. So big line, small line, that's my first battery, my first cell. Big line, small line, that's my second cell. And I've made sure that I've connected them the same direction, right? That way they're both pushing the electrons out this direction and pulling them back to this side. And 3-cell battery would look something like that. Once again, just 3 of them. Big, small, that's one battery. Big, small, next one. Big, small, next one. And once again, I've labeled it negative on the small side, where the electrons are being pushed out, and positive on the big side, where they're being attracted back in. So in a lot of our circuits today, we're going to start with the battery. We're only looking at batteries as our source of power today, but there is a slightly different symbol you can use if you connected it to the power grid. So you connected it to the power coming into your house. All right, so what are some of the other common things that show up in our circuits? And these are the diagrams that you'll actually use. These are the symbols that you'll use in your circuit diagrams. So in your circuit, you're going to need a wire. You need some sort of pathway for the electrons to move. So you just use a straight line to indicate a wire. And when you're drawing these, you do want to use a ruler and make sure it's a nice straight line. We don't have curved lines in circuit diagrams. In your circuit, you'll also have some sort of electrical load. So that could be a load, just means something that's using the electricity. So it could be a heating element, right? If you had a stove, for example. It could be a motor, if you had a fan, right? If you were spinning something. It could be some sort of antenna that's sending a signal, like in your cell phone. So anything that's using the electricity would be called an electrical load, or just a load. And a light bulb is also a load, right? It's using the electricity. We just have a special symbol for it because it's so common. So this is a symbol for a light bulb, any sort of light bulb. And there's often a switch that you can use to open or close your circuit, right? To turn it on or off, right? Like the light switch on your wall. So you can draw it in 2 different ways. So for example, this is a switch that's closed, meaning that it's on. And then this is a switch that's open, which means that it's off, right? The electrons can't flow down it. So that's the diagram for switches. And you could draw them either way depending on whether your circuit is running, right? Whether it's on, the switch is closed, or whether the circuit is not running, it's off. So the switch is open. Right? Because in this case, the electrons, they can't move across this gap, right? They need a complete pathway to flow. So they would just get stuck. They can't go anywhere. They can't flow down it. All right, so going back to this electrical load again. So what are some examples of electrical load? I mean, a light bulb, but we have a special symbol for that. Other ones I mentioned, a motor, right? If you wanted to spin or move something, if you wanted to run a fan, if you wanted to spin a wheel. Other electrical loads, a heating element, right? Heating element in your dryer, right? If you're drying clothes. If you have baseboard heaters in your house, the heating element in those. What happens in those materials is that the electrons, they actually move slower through the metal that they use in those. So they actually bump around and they release some of their energy as heat. They heat up that piece of metal. Or maybe a compressor. So this is a device in your fridge that moves the refrigerant in your fridge. So it keeps your fridge cool. Those are all examples. And there's many more. And this is just a quick note about the switches that we talked about earlier. So a switch is part of a circuit that is either closed, meaning the electrons are allowed to flow. Right? If you complete the circuit, if you close the switch down, the electrons can go through it. Or if it's open, then it stops the electrons from flowing. There is no path. Right? And just going back here, closed, the electrons are allowed to move through there. Open, the electrons can't. They're stopped. Your light turns off. All right, so let's draw a couple circuit diagrams here. So first one, we're going to draw a circuit diagram for this guy here. Okay, so here's kind of a picture of what's going on. So we have our battery or our cell, right? It has a positive and a negative end. And you'll notice a little arrow here with an E minus. That's the electron. So the electron gets pushed out of the negative end, right? Repelled by the negatives. It comes along here. It goes into, this looks like a switch, right? You can either lift this thing up to open it, or you can close it down like it is now. And right now it's closed, so the electrons can move through it. They come out the other end, they go into a light bulb, they go into another light bulb, back to the other end of the battery. So there is a pathway for electrons to flow. There is a path of copper, of conductors, that it can go all the way through. So the electrons will start to move. So this is a valid circuit. This circuit will work. All right, so let's start to draw here. What would our circuit diagram look like? Let's start with our battery. Okay, so I have a single battery, right? My negative is on the bottom side there, right? So the electrons are coming out the bottom. It's just a single cell, so I just have one battery. Then it looks like it goes to a switch next. So there's my switch, and my switch is closed, right? So the electrons can go through it. That's why the lights are on. And then I need a wire that's going to go up to the other side. So here's my wire, right? A line is just a copper wire. And then it goes through two light bulbs. So one light bulb, two light bulbs. And then I need a wire that just connects it back to the other end of the battery. There we go. That's my circuit diagram. So that represents this situation here. So if I was trying to tell somebody to build this circuit, right, I could just send them this diagram and say, okay, build this for me. And they would have all the information they need. You'll notice here that I've used straight lines everywhere. We always use a ruler and straight lines. And I've just used the symbols from earlier. All right, let's look at the next example. All right, so this one says draw a circuit that has 2 cells, a switch, a motor, and a light. All right, so at this point, I'll get you to pause the video, see if you can try drawing it yourself, and then we'll check back and see what you got. All right, so hopefully you had a chance to try drawing that one. Let's see what we got. So it looks like we have 2 cells. Okay, so there's my battery. You'll notice I've done it twice, right? Big, small, big, small. So 2 cells, 2 batteries attached together. Next thing it says is a switch so that you can turn it on or off. Okay, here's my switch. I decided to leave the switch closed because I'll assume that the circuit is running right now, but you could have drawn it open. It doesn't say, right? So it could be either. Then we have a motor. Oh, okay. So I've just kind of completed my circuit. So I have a wire and then I have a motor. Okay, my motor is the load that's using some of the power. So I'll just put that generic symbol for any sort of load like a motor. And there's also a light. Yeah, there's my light. And that's it. So I need to connect it back up to the end of the battery. There's my full circuit. All right, so what might the circuit actually be? It could be, for example, like one of those portable fans that you see people walk around with in the summer. But in this case, there would be a little trigger that's the switch, and then it would connect to a motor that spins the fan blade, and maybe there's a little light that turns on when it's on. All right, so there are a few practice questions I'll get you to do next, and these ones will get you to practice a bit more with drawing circuits. Before I let you go, though, let's just look at a couple examples of circuits. So these are the ones that we're kind of looking at today, right? Just a basic circuit. But I'll show you some of the other ones. So the next one here. So this is actually a circuit diagram for a hairdryer. So obviously this is much more confusing than what we're looking at here, right? But I wanted to quickly show you it though, because we can probably start to kind of notice a couple pieces here. So okay, obviously there's a lot of different components in your hairdryer. This is the symbol that we use for power that's coming from the power grid, so from the outlets in your house, right? So in this case, it's not a battery that it's running on; it's running off of the power grid. What are some things we notice here? Here's a motor. So maybe that's spinning the fan. Here it says that there are a couple different switches, right? So there is a switch where you can turn it on where it doesn't blow any heat, it just blows the fan. There's another switch which will turn on the heat. It looks like, right? I mean, there's some other symbols we don't recognize, right? But that's okay. I mean, these are actually called diodes that only allow electricity in one direction. But you'll notice that, as long as you knew what these symbols were, you could kind of figure out how it's built. Right? And we start to recognize some of these symbols now. This thing here is called a fuse. What this is used for is if your circuit shorts out. Instead of getting too hot and melting, what it will do is that fuse will just break, and it'll cause the hairdryer to immediately stop. So it's kind of a safety mechanism. We'll look at one more example. Okay, obviously this one is much more complex. This is the circuit diagram for a washing machine. So, okay, obviously there are a lot of pieces to it, but maybe we can start to kind of pick a couple of them out. So in this case, they're saying the power is just coming in from this end here. So they're not actually showing the source, but it's up here. But I mean, there's some pieces we can recognize, right? All right, here's a motor. Here's some switches, water selector switch, right? So maybe you can select, do I want my water to be, cold, warm, hot, right? Kind of a couple different switches there. Speed selector switch, right? There's a couple different switches in there. Select how fast it's spinning. Advanced rinse switch. Okay, do you want an extra rinse or not, right? That's another switch. Water level switch. Ooh, this one's a little bit weird. It's got kind of two different pathways that can go on. Right? But you'll notice, there's some symbols we don't know, but there are some that we do know, right? I mean, there's switches, there's motors. Um, this thing does eventually, right? It's pretty complex, but it does eventually come from one end of the power source and then come around and connect back up to the other end. So these are often, sometimes you can actually see these either in the manual for an appliance, like your fridge or your stove or your washing machine, or sometimes they actually stick it on the back of the appliance. And this can be used if someone comes to repair the appliance. So if they come to repair it, they might use this to figure out, where the different parts are or how they're connected.